Hello grade 9, this is chapter 6, section 3. The title of the section is Elastic and Inelastic Collisions. In this section we will identify different types of collisions. The first type is called elastic collision. The second type is called inelastic collision. In the first one, which is elastic collision, objects they tend to bounce away from each other. You can see this, for example, if two balls hit against each other, they will collide, they will move away from each other. In the second one, inelastic collisions, objects when they collide, they tend to stick to each other. You can see this clearly if you have two balls of mud, for example, and they collide, they will get stuck together. Or for example, in some car accidents, when the two cars collide, they will get stuck together after the collision. So we call it inelastic collision. So in other words, elastic collision, it's the non-sticky collision. Inelastic collision, it's the sticky one. It's the one where objects, they collide and they get stuck together. So in here, you keep in mind, while you are studying the two types of collisions, all kinds of collisions, all types, they undergo the law of conservation of collision. The law of conservation of momentum. In other words, the sum of momentums for the objects in collision before the collision equals the sum of the objects' momentums after collision. And here in this picture, you see that the two players here, after they hit each other or collide with each other, they will move as one big object. Okay, so what kind of collision is this? True, it's perfectly inelastic collision. And in this perfectly inelastic collision, you should keep in mind that the law of conservation of momentum is conserved, is valid. Okay, so momentum is conserved, and you can use this formula: m1 v1 initial plus m2 v2 initial equals. Now what you see here are the brackets in between them, mass 1 plus mass 2. Okay, why we added them? Because after the collision, what was m1, m2 as two separate objects, now it's the same object moving as one big mass, okay, having the same velocity. Remember when I told you in class that if you are riding a car, the car, the wheels, even the chairs of the car, all of you are traveling with the same velocity. So in perfectly inelastic collisions, when the two objects bounce and they get stuck, okay, you add the masses on the other side for the part of after collision. Now, as we always do, whenever you evaluate for velocity value, you should consider direction. Okay, so let's complete talking about perfectly inelastic collisions. In this type of collisions, the two colliding objects, they get stuck to one another. There is a missing R. Okay, now in here you should know that after collision, like in this picture, okay, you see here in this picture the two cars that are in collision or in accident here. Before collision, each one of them is having its own kinetic energy. After collision, you will notice that the total kinetic energy is not the same as it was before. You can ask me why it's not the same. We took before the law of conservation of energy, and that the energy before must be equal the energy after. This is true if there is no change in the form of energy. And here, what was kinetic energy before collision, after collision, you notice here sometimes you can see it clearly in car accidents when they collide with each other. You might hear a sound. Okay, so part of the kinetic energy is changed into sound energy. You might as well check that the temperature at the colliding part getting higher. So here we have thermal energy converted from what was before kinetic energy. So in perfectly inelastic collision, the total kinetic energy does not remain constant when the objects collide and stick together. Okay? There might be changes in the object's shape, size, or temperature. Examples as I mentioned here, one more time: two balls of mud moving toward each other, railroad cars coupling, or football players tackle. Now, let's start with the other type of collision, which is elastic collision. In elastic collision, it's the one that two colliding objects bounce away of each other. Okay, you can imagine any two billiard balls, for example. When they collide, they bounce away. Okay, now in elastic collision, there will be no form of energy produced other than the kinetic energy. Okay, so objects, they will not deform their shape, they will not change their temperature, so the total kinetic energy remains constant when the two objects collide. For example, as I said, billiard balls or air hockey pucks. Now, for the law of conservation of momentum, you will notice that the sum of the momentums of the two objects before equals the sum of the momentum of each object after. So no change on the law of conservation of momentum. It's the same familiar one to you. Now, and here in your book, I have highlighted all the parts that are required, all the sample problems solved that you can study from, and here the questions that you need to solve for this lesson. Any not highlighted part, you can just read it. Unless I write in a box related to it, do not study. Okay, and here you should observe that the sum, this half mv squared, it's the formula for kinetic energy. So in here you notice that the sum of the kinetic energy of both objects before collision equals the sum of kinetic energy of both objects after collision. Notice it's the sum that is the same. So the kinetic energy of the object itself might change, but as a sum, they stay equal. Okay, here you go, the questions that are required from you. And this picture represents one more time a summary for the whole lesson. You notice here the first one is called perfectly inelastic collision, where the objects, they collide and they get stuck together. The conserved quantity is only momentum. Kinetic energy is not conserved. In the second one, you have the elastic collision. The objects, they collide and then they bounce away of each other. You can read here, as I said, momentum and kinetic energy are conserved. Now, those are the first and the second collisions. They are considered to be the two extremes. Okay, and here objects, they get stuck and their kinetic energy is not conserved because part of it will be changed or transformed into thermal energy, while in here they will collide with no loss in kinetic energy. Okay, now those are the two extremes of collisions. Some of real collisions in real life, okay, objects, they don't stick to each other, but we can see it clearly that their kinetic energy has decreased. Okay, any kind of collision that is not perfectly inelastic or elastic, it goes under a third category, which is called inelastic collagen. Okay, the difference between the first and the last one here, according to the name, it's perfectly inelastic, while in the third one it's just inelastic. And here it involves the sticking of the two objects in collagen, while in here they don't actually stick, but their kinetic energy is not conserved according to the collagen. That's it, girls. I hope that you understood this lesson. Thank you.